All right, get this, you guys. Astronomers just found something in space, and it's making everyone rethink what we thought we knew about white dwarfs. I mean, we're talking like bizarre signals from space, maybe a whole new type of object out there.
Yeah, yeah.
And it brings up a lot of questions about, well, how stars live and die, you know?
Yeah, no, it's true. It could change how we understand stars completely. It's not just like, oh, a little thing.
Right,
This
right.
is big.
So everyone's talking about it, like all these research papers, articles, everything. They even gave it a name, this mysterious object, ILT J1101 plus 5521. But what's so special about it? I mean, what's got everyone like buzzing about this thing?
Okay, so it all starts with these radio signals, right? And they're strange. Imagine like pulses, each one like a minute long.
Okay.
And they happen every 125.5 minutes.
Oh, that's a long time.
Yeah. It's like clockwork, but like way slower than, those fast-spinning neutron stars, the pulsars.
Okay, so not your average pulsar then. That's a lot of time between signals. So where are these signals coming from? What's the source?
That's the thing. It seems to be coming from a binary system. So two stars together, and one of them is, get this, a white dwarf,
Okay.
like the dense leftover core of a star. After it's like burned through all its fuel,
Right.
we used to think they were pretty much dead,
Yeah.
you know, at least when it comes to strong radio waves.
Wait, so you're saying white dwarfs are blasting out radio waves? I mean, that's not how it's supposed to work. That's what pulsars do.
Yeah, exactly. I mean, that's why this discovery has everyone, so excited. It's like totally unexpected, like
great.
finding a penguin in the desert.
So what are we looking at here? Some kind of white dwarf, like trying to act like a pulsar?
Yeah, maybe. The main theory is that it's all about the magnetic fields, magnetic interactions. White dwarfs, especially if they're magnetic, they can make a lot of energy, especially when they've got another star nearby, like in a binary.
Okay, so it's like they're doing this cosmic dance, right? The two stars, and it like whips up this magnetic storm.
Yeah, that's a good way to put it. Their orbit, the way they dance around each other, that might be what's making those perfectly timed pulses.
You said that's the main theory. What other ideas are out there? What else could be going on?
Well, there's a lot we don't know, right? Like, what if there's a planet hiding in that system, a planet we haven't seen yet? Could that mess with the white dwarf's magnetic field?
Oh, interesting. Yeah.
Or maybe it's something even weirder. Like, what if this is a totally new type of magnetosphere, something we've never seen before?
Whoa. Okay.
I mean, there are a lot of possibilities.
Yeah, that's wild. So we've got white dwarfs acting like pulsars, hidden planets, and maybe even like whole new physics happening out there. Sounds like we might have to rewrite the astronomy textbooks.
Yeah, maybe. It's pretty exciting.
Definitely. But hold on a sec. Let's step back for a minute. I mean, this is all really cool, but why should, like, the average person care about this? Why does it matter to us here on Earth? You know what I mean?
I get it, yeah. It seems far out, right? But trust me, this has some big implications, like really huge implications for how we see the universe, for how we look for other worlds, the whole thing.
Okay, I'm listening. Give me the big picture.
Okay, so think about it. What if we've been totally missing a whole bunch of planets because of this? Like, we've been looking for planets around, normal stars, like our sun.
Right.
But what if white dwarfs, which are actually super common, what if they have planets too? And what if these planets are, like, messing with the magnetic field of the white dwarf and making these signals? It could change how we search for exoplanets.
Yeah, that would be a total game changer. So instead of just looking for a wobble in a star, like from the planet's gravity, we could look for these magnetic interactions.
Yeah, like a whole new tool.
That's pretty cool.
And get this, white dwarfs, they're what most stars become eventually, right?
Even our sun.
So by studying them, especially these ones in binary systems, it's like we're looking into the future of our own solar system.
Wow, so it's like a time machine almost. We're seeing what our sun might be like billions of years from now.
Exactly. And, who knows? Maybe some of those planets around white dwarfs, maybe they could even be habitable. It's a crazy thought, but it's possible.
It really is. Okay, so let's say we want to, like, prove this whole thing, Prove that this object, ILT J1101 plus 5521, is really acting like a pulsar. What would we need to see? What are the next steps?
More data. We need more data. Right now, all we have is radio waves. But what if it's also doing stuff in, like, X-rays or even visible light? Seeing it in different ways, that would give us, like, a more complete picture and help us rule out other explanations,
Yeah, it's like listening to a song on different speakers, right? You get a different part of the music from each one.
Perfect analogy. We need the whole orchestra, the whole cosmic orchestra, to really understand what's going on.
And while we're at it, maybe we should look back at like old data too,
Yeah.
right? From
Yeah.
those big radio surveys. There might be other white dwarf systems in there that we missed because they didn't look like normal pulsars.
That's right. We might have them already, just hiding in plain sight.
Makes you wonder how many other impossible signals are just, sitting there waiting for us to figure them out.
Yeah, it's humbling, right?
Totally. Okay, so you mentioned earlier that maybe some white dwarfs aren't as, dead as we thought.
Yeah.
What does that mean for, how we understand how stars evolve? Like, what are the implications of that?
Well, it means maybe our whole picture of how stars live and die, maybe it needs an update. We used to think white dwarfs were the end, like the final stage.
The embers.
Yeah, fading away. But now we're seeing that they can be a lot more active and energetic, especially if they're hanging out with another star in a binary.
So it's not just a quiet fade out for these white dwarfs.
Yep.
They still have some tricks up their sleeve.
They do.
Especially when they've got another star, to stir things up.
Exactly, like finding out your grandparents are secretly stunt performers.
Haha. I love that analogy. Makes you wonder what other surprises these white dwarfs have in store for us.
Right. It's a huge area of research. And one of the most exciting things is, the possibility of habitable planets around these undead stars.
Wait, hold on. Habitable planets around white dwarfs. Isn't that, a little bit crazy? I thought white dwarfs were, dying stars.
Yeah, they're the leftovers, right? After a star runs out of fuel.
Mm.
But that doesn't mean they can't have planets or even, habitable planets. We've actually found evidence of planets around white dwarfs, and some of them, well, they might be in the right spot for liquid water.
So we're talking about planets that could have life on them, orbiting around what's left of a dead star. That's mind-blowing.
It is pretty amazing. But there are a lot of things that have to be just right, of course. Like, the planet has to be the right distance from the white dwarf for the temperature to be good for water.
Right. Habitable zone.
Yeah. And the orbit has to be stable, which can be tough in a binary system.
All right.
And then the planet needs the right kind of atmosphere, the right stuff on it, for life.
Yeah, it's complicated.
It is. But we're starting to understand more and more.
This is crazy. So we might not have to look just around stars like our sun for life. Maybe white dwarfs are where it's at.
Maybe.
Yeah.
It really shows how much we still have to learn about, what makes a planet habitable. Life might be a lot more resilient and adaptable than we thought.
It's kind of humbling and exciting at the same time. Okay, so we've got these white dwarfs acting like pulsars, maybe with habitable planets, and maybe even changing how we think about how stars evolve. What's next? What are the big questions we still need to answer?
Well, the big one is, are there more of these white dwarf pulsars out there? If this is happening a lot, then it changes everything. And we need to get better at explaining how these magnetic interactions actually work and how they affect those binary systems.
Yeah.
And of course, the hunt for planets around white dwarfs is just getting started. I think there are a lot more surprises waiting for us out there.
Sounds like a whole new chapter in astronomy is opening up with white dwarfs in the spotlight.
Yeah, and who knew those dead stars had so much going on?
It's pretty incredible. This has been an amazing deep dive. We've talked about some seriously mind-bending stuff, from strange signals to, the possibility of life on planets orbiting the remains of dead stars. It's been a wild ride, and thanks for, taking us through it all, for sharing your expertise.
Happy to do it. I love talking about space, and I hope, we've gotten everyone excited about what's out there.
And to all our listeners, we say, keep exploring, keep asking questions, and never lose your sense of wonder. The universe is an amazing place, and there's always something new to discover. Until next time, keep looking up.
Is a fascinating area of research.
Yeah.
And one of the most exciting implications is this possibility of habitable planets around these undead stars.
Hold on. Habitable planets around white dwarfs. Isn't that a bit of a stretch? I thought white dwarfs were, dying stars.
You're right. They are the remnants, right, of stars that have used up all their nuclear fuel. But that doesn't mean they can't have planets, even, potentially habitable ones.
Yeah.
We've found, actually, evidence of planets around white dwarfs, planetary systems.
Wow.
And some of those planets, well, they could be in the right zone for liquid water to exist.
So we're talking about planets that, could support life orbiting around the embers of a dead star. That's pretty amazing.
It is pretty mind-blowing.
Yeah.
But there are a lot of things that have to be just right, of course. Like, the planet has to be in the habitable zone, the right distance from the white dwarf.
Right, for the temperature.
Yeah, so the temperature is right for liquid water.
Yeah.
And the orbit has to be stable, which, that could be tricky with a binary system.
Right.
And then the planet needs the right kind of atmosphere, the right composition to support life, as we know it.
Yeah. There's a lot that has to go right.
It is a complex puzzle.
But it sounds like we're starting to figure it out.
Yeah, the pieces are coming together.
This is crazy. It really changes how we think about, where we might find life out there in the universe. I mean, we've been so focused on stars like our sun.
Right.
But what if, white dwarfs are where it's at?
Yeah, what if? It shows you how much we still have to learn about habitability. Life might be more resilient than we thought, more adaptable.
It's pretty humbling and inspiring at the same time. Okay, so we've got white dwarfs, potentially with habitable planets. They're acting like pulsars, and maybe even changing how we understand, the whole life cycle of a star. What's next? What are the big questions we still need to answer?
Well, one of the biggest is, are there more of these white dwarf pulsars out there? If we find that this is common, it changes everything.
Right.
And we need to develop better models, better ways to explain how these magnetic interactions, how they actually work and how they affect those binary systems. And, of course, the search for planets around white dwarfs is just getting started, really.
Yeah.
We've only just scratched the surface. I think there are going to be a lot of surprises.
It sounds like we're entering this, new era in astronomy where white dwarfs are, front and center.
Yeah, who knew those dead stars had so much going on?
Yeah. It's pretty incredible. This has been an amazing deep dive. We've talked about some, seriously mind-bending stuff. From those strange signals to the possibility of life on planets orbiting, what's left of a dead star.
It's been a wild ride.
It really has. And thanks for, taking us through it all, for sharing your expertise.
Oh, it's been my pleasure. I always love talking about space, and I hope, we've inspired everyone listening to keep looking up and keep asking questions.
And to all our listeners, we say keep exploring, keep learning, and never lose your sense of wonder. The universe is amazing, and there's always something new to discover. Until next time, keep those cosmic fires burning.
It means that we might need to, revise our picture of how stars live and die.
Oh.
We used to think of white dwarfs as the final stage, the fading embers of a star's life.
Right.
But now we're seeing that they can be much more dynamic, much more energetic.
Yeah.
Especially when they're interacting with other objects in a binary system.
So it's not just a quiet fade out for these white dwarfs.
Nope, not at all.
They've still got, a few tricks up their sleeves.
They do.
Especially when they've got a companion star to, stir things up.
Exactly. It's like discovering that your grandparents are secretly leading a double life as, stunt performers or something.
Ha, I love that.
It challenges everything you thought you knew about them.
Totally. It makes you wonder what other surprises white dwarfs might have in store for us.
Well, it's a vast and fascinating area of research.
Yeah.
One of the most exciting implications of this discovery is, this potential for finding habitable planets around these undead stars.
Wait, hold on. Habitable planets around white dwarfs? Isn't that a bit of a stretch? I thought white dwarfs were, dying stars.
Yeah, you're right. There are the remnants of stars that have exhausted their nuclear fuel.
Right.
But that doesn't mean they can't support planets.
Okay.
Even potentially habitable ones, We've actually found evidence of planetary systems around white dwarfs.
Oh, really?
And some of those planets might be in the right zone for liquid water to exist.
So we're talking about planets that could theoretically, support life orbiting the embers of a dead star. That's mind-blowing.
It is a mind-boggling thought, yeah. But for a planet to be habitable in such an extreme environment, well, a lot of things have to be just right,
Right.
For starters, the planet would need to be in the habitable zone, obviously, where temperatures are right for liquid water.
Right.
I would also need, a stable orbit, which can be tricky considering the gravitational dynamics of a binary system.
Right.
And then, of course, the planet would need to have, the right kind of atmosphere and composition to support life as we know it.
Yeah.
It's a complex puzzle, but, the pieces are starting to come together.
This is here. This really flips the script on where we might find life in the universe, We've been so focused on stars like our sun.
Yeah.
But what if white dwarfs are harboring these, hidden oases for life?
It's a tantalizing possibility.
It really is.
And it just underscores the fact that our understanding of habitability is constantly evolving.
Right.
We're learning that life might be more resilient, more adaptable than we ever imagined.
It's both humbling and inspiring. Okay, so we've got these white dwarfs behaving like pulsars, potentially harboring habitable planets, and maybe even rewriting the rules of stellar evolution. So where do we go from here? What are the next big questions that we need to answer?
Well, one of the key challenges is to find more of these white dwarf pulsars, right?
Yeah.
If we can confirm that this phenomenon is widespread, it would revolutionize our understanding of these objects.
Hmm.
We also need to develop better models
Right.
to explain how these magnetic interactions work and how they might influence the evolution of binary systems.
Right.
And of course, the search for exoplanets around white dwarfs, well, that's just getting started.
Yeah.
We've only scratched the surface, and I have a feeling there are many more surprises waiting to be discovered.
It sounds like we're on the cusp of a like a new era in astronomy where white dwarfs take center stage. Who knew those dead stars had so much life left in them?
It just goes to show that the universe is full of wonder and that we're constantly learning new things.
Yeah.
Every discovery opens up new avenues for exploration, and, well, I can't wait to see what the future holds.
Me neither. It's an exciting time to be, following astronomy. And I'm sure our listeners are just as eager as we are to see what mysteries the universe will reveal next. Well, that brings us to the end of our deep dive into white dwarf pulsars. We've covered a lot of ground today, from bizarre radio signals to the mind-blowing possibility of habitable planets orbiting white dwarfs. It's been an incredible journey, and I want to thank you for, sharing your insights and expertise with us.
Oh, it's been a pleasure. I'm always happy to talk about the wonders of the universe, and I hope we've inspired our listeners to, keep looking up and asking questions.
Absolutely. And to our listeners, we say, keep exploring, keep learning, and never lose your sense of awe. The universe is a vast and mysterious place, and there's always something new to discover. Until next time, keep those cosmic fires burning.